power reducing identities. So if we have sine squared of theta, we can reduce it down to 1 minus the cosine of 2 theta divided by 2. If we have cosine squared of theta, we can reduce it down to 1 plus the cosine of 2 theta divided by 2. And if we have tangent squared theta, it equals 1 minus the cosine of 2 theta divided by 1 plus the cosine of 2 theta. So we're going to modify the left-hand side until we get the right-hand side. So what we see is 1 minus cosine of 2 theta over 2. Well, we know that the cosine of 2 theta is equivalent to 1 minus 2 times sine squared of theta, all of it over 2. And that's one of our earlier identities that we went through, that the cosine of 2 theta, there are several options for that, but here we can go with the 1 minus 2 times sine squared of theta. And so if we simplify, 1 minus 1 plus 2 sine squared theta divided by 2 so we have 2 sine squared theta divided by 2, and we will get sine squared theta. So that's why this is always true. Sine squared theta will always equal 1 minus the cosine of 2 theta divided by 2. All right, now we're going to use a power reducing identity. So we're going to rewrite cosine to the 4th power of x in terms of trigonometric functions with no power greater than 1. Okay, so we could rewrite this as the cosine squared of x being squared. And then our power reducing identity tells us that cosine squared of theta is equal to this, 1 plus the cosine of 2 theta divided by 2. Oops, it should be 2x for this one though, because we're using x, not theta. That's our variable. Okay, so if we multiply this out, we'll get 1. Remember, we'll have to use FOIL here, so we're doing 1 plus cosine of 2x times 1 plus cosine of 2x. Gotta use our proper algebra skills. So 1 times 1 gives us the 1. We'll have cosine of 2x plus cosine of 2x. So it's 2 cosine of 2x, and then plus cosine squared of 2x. And then in the bottom, 2 squared gives us 4. Okay, so if we individually divide, we have 1/4 plus 1/2 times the cosine of 2x plus 1/4 times the cosine squared of 2x. So then we can replace that cosine squared of 2x with the power reducing formula. So 1 plus cosine of 2x divided by 2, sorry. There we go. And so if we simplify, we have 1/4 plus 1/2 cosine of 2x plus 1/8 plus 1/8 cosine of 2x. And so, nope, because it was 2x. I gotta go back. It was already 2x, so now it becomes double that, so it should have been 4x here. Sorry about that. Because we already had 2x when we do our power reducing formula, we gotta double it, so it needs to be 4x. So let me fix that little mistake here. And so now we can add together our constants, so we can at least combine these. So 1/4 would be 2/8 plus the 1/8 gives us 3/8 plus 1/2 cosine of 2x plus 1/8 cosine of 4x. Or if you want it in factored form, 1/8 times 3 plus 4 times the cosine of 2x plus the cosine of 4x. Either one of those would be acceptable. And so those are our power reducing formulas. They can be really useful when you move on to your calculus work.